Hello, I'm here with Professor Michael Weeks from the Georgia State University. Professor, welcome.
Thank you. Good to be here.
I have a question for you. What are you currently working on?
Currently, I'm working on artificial intelligence with gaming as the area that I'm specifically interested in working in. And one of the things that means is that we may have agents, that is characters within the game, that may need to act on their own. And we want them to be good, at least entertaining. So if they're too easy, say as an opponent, that's a problem. If they're too good as an opponent, that's also a problem. And sometimes we just want them to be there and sort of act natural as well.
Got it. And Professor, what inspired you to choose this topic for your research?
I have always loved games. And I've been playing games since I was this high. I'll probably keep playing games until I'm old.
Which one is your favorite?
My favorite game? I play a lot of Skyrim right now. Yeah. Although I really enjoyed the Zelda series, like Tears of the Kingdom, Breath of the Wild before that, and whatever they come up with next, I guarantee you I will be first in line to buy.
Awesome. I can see that you are really passionate about gaming and the games. Can you explain the main idea of your research paper in simple terms?
So, a lot of people use neural networks for a lot of different things, and there's a question of how do you train the neural network to do what it needs to do. There's a sort of a default method that everyone wants to use called backpropagation. The problem, though, is that it doesn't always work under every domain, and I think games are a great example of that. Because if maybe you make a new game, and you want to have an agent that works within that game world, it may be that if the agent goes this way, it's going to end up dying, and then
right.
That's it for the agent. Maybe if they go this way, they also end up dying. But perhaps it's a little more interesting. Maybe they're in the game world longer if they go this way. Well, you're not going to be able to know this necessarily, even as the game designer. So the agent may need to be able to figure this out themselves. How do they do that? Well, they may be able to play the game again and again and again and again, but you don't have a way of telling them, well, turning to the left, that's a problem, you shouldn't do that. It needs to be able to figure that out without any data from before.
Mm-hmm. And what was the most interesting finding of your research work?
One of the things that really surprised me is that we populate the weights for the neural network with random data. We just give it a bunch of, almost like we're rolling the dice, if you will. Mm-hmm. One of the sets of weights actually solved the problem that I was looking at initially. Mm-hmm. It's a pretty simple problem, but still I didn't expect that just a random solution would work. So that was particularly surprising to me. So I did another test, something a little more complicated, and eventually it was able to learn in the two different ways that I asked it to do the learning.
Right. And what challenges did you face while conducting your research work?
One of the problems is how do you represent a number in a computer? And I know that sounds like a pretty easy thing to answer, but do you use a floating point value that is a number that has a fractional part? And if so, do you use, say, a 32-bit value or a 64-bit value or a 128-bit value? Where do you draw the line? Then I found that Google had actually done some work on something called a bfloat16, and that answered the question for me. I think I used this analogy before. It was almost like I was hacking my way through a jungle and then suddenly came upon a paved road.
I really like that analogy. And what about some real-world applications of your research work?
Anytime that you need to train a neural network and you don't have data from before that you can tell it this is right and this is wrong, I think there's an application there for what I used called a neuroevolution. And that's where you can let the agent, say, try and fail on its own, and then go back and make some changes and let it try again.
Mm-hmm. Let's look into the future. What are some next steps for your research work?
for my research work, I'd like to apply this to more larger problems and see where that goes. I did get a question or two from the audience, and one person was asking about, well, what if you change the architecture for the neural network? How would that impact things? And that would be an interesting thing to look at as well.
And what about the conference itself? How was your experience so far?
Well, this is a fantastic location. I've been really happy here at the conference. It's well run. It seems that the organizers have done a really good job of trying to get people to talk to one another. I think as academics, we tend to want to just stand by ourselves and not talk to anybody, but we've been able to break the ice and talk to each other and make some friends along the way.
Professor, thank you so much for your time.
Thank you.